Good evening, everyone. Uh, Welcome to this tutorial session. So today we'll be discussing week 7 assignments of the previous iteration of this course. This is the course on social networks. So let's get started. I'll start sharing my screen. I hope my screen is visible to everyone. So let's start with the questions. So we have 10 questions. We'll discuss the solution to each one of them. So if you have a doubt, you can interrupt in between or you can ask at the end as well. So coming to the first question. So which factors influence diffusion? So you have three factors: payoff, key people, and cluster formation. So diffusion is basically if you have a network, let's say uh, this is your network. So and it, it's connected in a certain fashion. So diffusion is, let's say there is a idea at this particular node. So diffusion is how this idea spreads across the entire network. So does it spreads far or does it spreads only to a few neighbors and stop spreading? So this phenomenon is known as diffusion. So So the factors that affect diffusion are, so payoff. Payoff is basically each payoff is each node's um, reward for accepting a new idea. So every node accepts a new idea based on a certain payoff value it has. So that is known as the payoff. Key people are people with large connections. With large connections in the network, and cluster formation refers to closely knit people in network. So the factors that affect the spread are payoff. So payoff definitely affects the spread because every node will decide on what reward it gets for accepting the new idea before passing it, adopting it and passing it on to further neighbors. So definitely payoff is one of them. Key people, people with large connections in the network, they will be able to spread that idea to a large number of people. So key the if an idea is propagating through some key people, the chances that the idea spreads further in the network are high. So key people also play a role. Cluster formation, so a closely knit people will be very difficult to persuade a new idea because they will mostly be influenced by their own group, the closely knit group that they belong to, rather than some external factor. So cluster formation prevents the spread of further ideas. So option 3 also plays an important role in diffusion. So the right answer is all three. So here the option is D. So option D is the right answer for this question. Moving on, uh, coming to question 2. When is it easy to convince a community to adopt new ideas? A, when the density of the community high is high and B when the density is low. So if we divide the communities as high and low densities, when when the density is high, likely to be influenced more by people in same community, and if it is low, then chances of external influences are high. So which means that if the community has high density, so most of the friends would belong to the same community, and therefore if the current existing friends do not have a certain new idea and an external factor is trying to push a new idea into the community is not likely to be influenced because they will give more weightage to the friend who are in the existing community, which is higher than what the number of friends they have outside of the community. But if it is low, in which case the chances of external influences increases because they have low influence from the community itself. So therefore, when the density of the community is low, it is easy to convince a community rather than when the density is high. So any questions so far on all right, so moving on to the next question. Coming to question number 3. If in a social network, an idea starts from one person and slowly reaches other parts of the network, so what is this phenomenon known as? So as we know, the theme of this assignment is this topic itself. So it's diffusion. So how an idea spreads over a network. So the right answer for this question is diffusion. I don't think there is further explanation necessary for explaining. Coming to question 4. So the density of a cluster D is D if, so you have three options. The average friends of all nodes inside the cluster is D. D fraction of the nodes friends are present inside the cluster and D fraction of the nodes friends are present outside the cluster. So let's take a particular node which belongs to a cluster. It has a certain number of friends. They belong to the cluster. The right hand side denotes that they belong to the cluster and the left hand side denote do not belong to cluster. Cluster is basically a group of nodes. So cluster density is basically is the ratio of friends in cluster to total friends. And this is the cluster density and you take the minimum of this. So which means that if a cluster density is D, density D, it denotes each node in the cluster, each node in the cluster has at least D fraction of friends within the cluster. So the right option is B. So D fraction of the nodes friends are present inside the cluster. Coming to question 5, if the payoff of watching a documentary and listening to songs is zero point 0.5 and zero point 0.4 respectively, four of your friends decides to watch movie and six of them to listen to songs. Which one should you pick? So basically you have two choices: watching documentary or listening to songs. So what's the payoff? Payoff for watching a documentary is zero point 0.5 and payoff for listening to songs is zero point 0.4. Number of friends. So your decision is going to be affected by your friends. So number of friends who have decided to watch documentary. So four of your friends decided to watch movie. So movie and documentary are used. They mean the same thing over here. So four decides to watch movie and six of them to listen to song. So total payoff is 4 into 0 0.5, which is 2, and total payoff for songs is zero point 0.4 into 6 is 2.4. So in such a setting, what will you choose? So the total payoff you are weighing for watching documentary or movie is 2, and that for listening to songs is zero point 0.4. So you, since 2.4 is greater than 2, so this is the winner. So what you decide is to watch, is to listen to songs. So listen to songs would be your decision. This is how payoff is how diffusion is modeled. It need not be necessary that you would be listening to songs, that but the chances of your listening to songs is much higher compared to watching a documentary under such a model. Coming to question 6. So question 6, you have uh, three scenarios. So if the value of the node is its threshold, so this value above each node, this number uh, given uh, beside each node represents its threshold value to join a protest, then in which of the following graphs protest is likely to happen? So let us consider each of the three options one by one. So let us consider the first option. So you have three nodes A, B, C, and with threshold value 2, threshold value C. A's threshold value is 3, B is 2, and C is 3, which means that A needs at least two more people to join him in the protest. So threshold, so threshold is minimum number of people needed to join in a protest. So A will join the protest if A is sure that at least three people will be joining the protest, including itself. So if B and C joins the protest, then A can go ahead with joining the protest because its threshold value is 3. So let us first assume that in this scenario, in option 1, all three of them decides to go for the protest. Now let us check whether it matches, whether it uh, causes any contradiction with its threshold value. So for A, B and C both decides to go for the protest, and A is friends with B and C. So A knows that B and C are going for the protest, and and since its threshold value is 3 and it itself can also go for the protest, so three people A knows for sure are joining the protest, and his threshold value is 3. So A will definitely stick to the protest. So it will continue with the protest. For B, so B, for while deciding B, so B knows that A has gone for the protest and C has gone for the protest, and it since it's friends with A and C, and its threshold value is 2, it needs only one other extra person to join in the protest, and now you have 2 persons, so its threshold value is also satisfied. For C considers, let's say, A and B joins the protest, and C's threshold value is 3. So can also join in the protest given that A and B are also joining. So the threshold value of C is also satisfied. So there is no problem. So they will go for protest. Coming to option 2, again, let us assume all 4 of them goes for the protest, and we'll check node by node if there is a contradiction with the threshold value. So coming to node A, Node A, all of them goes for the protest, and Node A is friend with B and D. It knows that B and D has gone for the protest, and and itself can also go for the protest. So 3 people are in the protest. A knows for sure, so its threshold value is satisfied. Coming to Node B, B knows A and C has gone for the protest, and suppose B can also go for the protest. So B knows that at least 3 people are coming for the protest, but its threshold value is 4, which is more than 3. So B doesn't want to go for the protest because its threshold value is higher. So its threshold, it knows for sure that 3 people will come, but it needs at least 4 people to be present in the. So B will drop out of the protest. So here a contradiction arises. So this group will not go for protest. Will not likely go for protest. Coming to the third option. So again, we assume all 4 of them goes for the protest. And let us check node by node. A goes for the protest. It knows B and C also goes for the protest since it's friends with B and C. Therefore, 3 people it goes for the protest. A knows for sure 3 people will come for the protest and its threshold value is 3. So A definitely goes for the protest. For B, it knows A and C goes for the protest, and it itself goes for the protest, and its threshold value is 3. So it knows at least 3 people are coming. So B is also in. For C knows that A, B, and D are going for the protest and itself is going. So it knows that at least 4 people are coming for the protest, whereas its threshold value is 3. So it definitely goes for the protest. Coming to D, D knows that only C is going for the protest and its threshold value is 2. Therefore, D has no problem going for the protest as well. But if in this case, if this 2 happen to be 3 or higher, then D would not have joined in the protest because it knows only that C is coming, at least C is coming. For others, it don't know because it's not connected to the other. So in that case, D would be unsure to join the protest. So therefore, in that case, protest wouldn't happen. But since it is 2 for D in the given problem, this group will likely go for protest. So the first and third option are likely to go for protest, whereas the second options is not likely to go for protest. So the right answer is option D, 1 and 3. Is there any question so far? Uh, all right. Then we can move on to the next question, which is question 7. The technique in which we identify key people in the network using which the ideas get spread very fast. So is it diffusion, viral marketing, randomness, or clustering? So key people have high connections. So example would be celebrities. So they they can spread it to spread an idea. An idea to a large number of people. So the right answer would be viral marketing, where a sudden increase in idea is suddenly is exposed to a large number of people in the network. So that is known as viral marketing. So option B is the right answer for question 7. Okay, moving on to question 8. So coming to question 8, the payoff for watching movie and studying for Ram is P and Q respectively. He has 20 friends, out of which 8 decides to study and remaining decides to watch movie. If he decides to study, which of the following option is correct? So you have movie and you have study. Payoffs. Payoff for movie is P. Payoff for study is Q. Friends, number of friends for watching movie is 20 minus 8, that is 12. And number of friends for uh, for studying is 8. So total payoff is 12p, and total payoff for study is 8q. So for for deciding to study, if uh, Ram is de- if Ram decides to study, in which case uh, total payoff for study should be greater than uh, total payoff for movie. So total payoff for study is 8q and total payoff for movie is 12p, which is 2q greater than 3p. So 2q greater than 3p. So option B is the right answer in this question. I hope, is it clear to everyone? So this moving on to question 9. A cascade cannot be complete in a network with threshold of adoption equal to k if there exists a cluster with density. So suppose a node, consider this node. It has certain, let's say q and 1 by 1 minus q. So we are splitting the friends of this particular node which belongs to a cluster, and an idea here, this side are new idea, and this side is a cluster. So the nodes on the right hand side belong to the cluster, and the nodes on the left hand side are already have adopted the new idea. So whether will will this node adopt new idea? So in this case, it adopts a new idea if q. Let us just for simplicity call it p for now. Means adopt new idea if P is greater than equal to Q. So this particular node over here, let's say node A will adopt the new idea if it's if the ratio of friends that have adopted the new idea is greater than the threshold Q, and it refuses if uh, if P is less than Q. So when will such a situation arise that if P is less than Q, then 1 minus P would be greater than 1 minus Q. So the fraction of friends in the cluster, which means this one- fraction of friends in cluster should be greater than 1 minus Q. So the density of the cluster is basically the fraction of friends in the cluster. So the density, this is basically means density of cluster should be greater than 1 minus Q. So the right answer is option D. So if the density is greater than 1 minus Q, this node will not adopt the idea and the cascade will fail. So will not be complete. The cascade will not be complete in a network. It means that it means that idea does not spread to entire network. So the idea stops propagating to the entire network. So that's how the propagation stop, and therefore the if the cluster density is greater than 1 minus Q, in which case the idea will not spread through such a node which belongs to a cluster if the cluster density is greater than 1 minus Q. Coming to the final question, so which of the following factors can cause problem in adoption of a new idea in a network? So is it high payoff, high threshold value, cluster density greater than 1 minus threshold value, and cluster density is greater than less than 1 minus threshold value? So if the uh, a- for adoption, if the payoff is high, then chances are of adoption is easy. So there won't be any problem to adopt a new idea if it gives a high payoff. Therefore, one is not a correct answer. So whether high threshold value, if a high threshold value will affect adoption. So a node with high threshold value has to cross the high payoff, has to the payoff of the idea should cross the threshold value of a particular node to be adopted. Therefore, if the node has a high threshold value, then the idea won't be adopted by the particular node. So high threshold value can cause problem. If cluster density is greater than 1 minus threshold value, just in the previous problem, like I described, the idea won't be affect will not propagate into this cluster because more friends of the nodes are present within the cluster compared to outside. So it will be influenced by nodes within the cluster which doesn't have access to the new idea. So therefore, cluster density is greater than 1 minus threshold value, the idea won't be adopted. So this can cause problem. And since this so cluster density less than 1 minus threshold value won't be a problem. The idea will be easily adopted. So option 2 and 3 are the correct answers for this question. So now we have discussed all the 10 questions for this assignment. So if you have any doubt regarding any of the questions, you can ask, you can unmute yourself or type it in the chat box as well. Does anyone have any question regarding any of the question, any of the problem that were discussed? You can type it in the chat box as well. If you want, I can repeat I can repeat any of the questions if you have missed anything. Okay. Are there any more questions? All right then. So if no one has a question, we can close the session for today. Tomorrow the session will discuss week 8 questions and we'll meet again next week. So thank you everyone for joining in. You may leave. Okay, someone has a question. How to calculate community density and cluster density? So, okay, so this can be a confusion. So community density and cluster density. So community density is basically the ratio of total number of edges within community by total number of edges possible within community. And cluster density is basically the minimum of number of friends inside cluster to total number of friends. Total friends. So they are two different things. So cluster density is you find this ratio for every node that you consider within the cluster and then take the minimum. For a community, you consider all the nodes at once and then find the edges within the community and then total number of edges possible within the community. So that is how cluster density is. Okay, someone is asking how to explain with a graph. So let's say you have 4 nodes. So maybe this is your community. So in your community, we have 4 nodes. So the total number of edges present is 3 and total number of edges possible is you have 4. So 4C2. So this is 3 over 6. So this is half. So this is the community density is half. And cluster density. So in a cluster density, so if you considered, okay, the same kind of graph. So you have this. same graph, but they have also some friends outside. Let's say here, so maybe this, and let's say the fourth node doesn't have. So plus, what is this ratio? So number of friends inside clustered by total number of friends. So for this is 1 by 2, half. So total number of friends is 2, 1 here, 1 there. And inside there is only one friend in the cluster. For this node, number of friends inside cluster is 2 and total number of friends is 3. So 2 by 3. For this node, number of friends is 1 and it doesn't have any friends outside. So 1 by 1. And for this node, again, it has 2 friends within the cluster, but total 3 friends. So this is the cluster density. Now the cluster density is the minimum of this. So minimum is basically half. So half is the cluster density of this cluster. So that is how cluster density is calculated. I hope that is clear. Okay. Uh, any further question? If there are, okay, someone is asking to repeat question 2. Okay. So, okay, so question 2 is asking, when is it easy to convince a community to adopt a new idea? So, let us say this is your community. Let's say these 5 people belong to a community, and let's say they have certain connections among themselves. So maybe they are connected in a certain passion. Okay. So let's say this is a particular community, and now we have, let's say, some other nodes as well. So these nodes are trying to inject a new idea into this community. So the question is, will this node, will this node accept a new idea, or the will this node or any of this particular node, so any of this nodes accept this new idea? So if the community density is high, which means that this particular, let's say, node A is influenced more by node A, influenced more by people of the community than people outside. So in which case the net payoff of a new idea would likely be less than net payoff of old idea. So in such a case, A will not adopt a new idea. So in this is a high density community. But if the density was low, then A's most of the friends would have been like would not have belonged to it. A wouldn't have been influenced by the community as much as in this high density case. So the chances of A getting influenced by outside ideas is higher. So when the density of the community is low, the it is easy to convince the community to adopt a new idea, because the payoff of the new idea will outweigh the payoff of the old idea as influenced by the members of the community. uh, okay. Someone is asking to explain week question 6 and 8. Okay, let us question 6 and 8. So question 6 is basically whether you have you have three networks given with the values referring to the threshold to join a protest, and we have to decide that which of these networks is likely to join a protest and which is not. So if you consider the three networks separately, so let us consider first the network 1. So you have three nodes A, B, C, and threshold is given 3, 2, 3. So now let us first assume that all of them are going for a protest. Now we'll check if any contradiction arises with the threshold values of each node. For first, initially, we assume that all three are going for protest. Then A knows B and A knows C. So the edge refers to that A knows is that B is joining the protest. A knows that C is joining the protest, and A itself can is also joining the protest. So it A knows that at least three people are joining the protest and its threshold value is 3. So A will join the protest. For B knows that A is joining the protest and it itself is joining the protest, as well as C is joining the protest. So B knows that at least three people are joining the protest and its threshold level is only 2. It's it's all the better for B to join the protest. So B will easily join the protest. For C knows that it itself is joining the protest. A and B are also joining the protest. So three people, C knows for sure that three people are going. So C will also join the protest. So there is no contradiction with the threshold value of any of the nodes. So this network is likely to go for the protest. Coming to the second one, uh, so in second one, so you have the protest thresholds are 3, 4, 3, and 2. For again, we assume that all of them are going for the protest, uh, in which case let us check again for node A. So node A knows that B is going for protest and D is going for protest and itself is going for protest. So at least three people are going for protest and its threshold value is 3. So A will join the protest. But coming to node B, it knows A is going for protest, C is going for protest and itself is going for protest. So it knows that three people are at least coming, but its threshold value is 4. It doesn't but since 3 is less than 4, B will not be very keen to join the protest and might back off, in which case the entire network is not likely to go for a protest as a whole. So network 2 won't go for a protest. Coming to network 3, again we assume all of them are going for a protest. For A knows B is going, C is going, and itself is going. So three people are going, and its threshold value is 3. So A goes. For B, it knows A goes, C goes, and itself goes, and its threshold value is 3. So 3, no problem. For C, it knows that A, B, and D, all three are going, and itself is going. So 4 people it knows are going, and its threshold value is 3. So C will likely to join the protest. And for D knows only C is going, and itself is going. So 2, and its threshold value is also 2. So therefore it's easy. So D is likely to join the protest as well. So there is no contradiction with anyone with the node. So only option 2, it's unlikely that this group will go for a protest, but option 1 and 3, the group is likely to go for a protest. Okay, coming to question 8.
Hello, sir.
Yeah,
Sir, I was asking will you explain assignment 7, question number 6 or 8?
assign this is week 7 only, right?
No, sir. I
Uh,
mean the actual
this
assignments.
Oh, no, actual assignments we won't discuss here.
Okay.
That is
Okay.
for like you will be graded based on that.
No, I mean, sir, the assignment is over. The marks are have given to us. That's why I was asking.
Oh, okay, so no, like you can. So we didn't check those assignments. So we are discussing. This is from last year's questions we are discussing. So I have not prepared for this year's question. So if you have a doubt, you can. I can mail you the. If you have any doubt, you can write me a mail and I can send you the solutions. But for now, for this class, I have not looked into what as the solution of this year's question was. So I can give you my mail ID or you can type it in the chat box which question you want to discuss and give your email ID. I will send you the explanation if you have any doubt.
Okay, sir.
Like
Okay, sir.
yeah,
Thank you, sir.
yeah.
Sir, then, sir, the question number eight will, I think, I know what is question number eight, so don't need to explain it.
Oh, okay, okay. Okay, so someone is asking for question 9. Okay, so question 9. Okay, so my mail ID is So this is my mail ID. You can send me your doubts. I'll take a look and get back to you. Okay, so coming to question 9. So a cascade cannot be complete in a network with threshold of adoption Q if there exists a cluster with density 1. So cascade cannot be complete. It means that the idea does not spread to the entire network. So when does an idea does not spread to the network is if you have a particular node that doesn't there exists at least one node that refuses to adopt the idea. So let's say this this is a particular node A and it belongs to such a cluster. So let's call the cluster as cluster is the uh, collection of nodes with collection of nodes which refuses new idea. So these are the all the nodes that did not adopt the new idea and because of which the idea did not spread across the entire network. So let us call this a cluster. Now we pick one such node A from this cluster. So the question is, will this node adopt the new idea or not? So we have this distribution of friends of this node. So P friends are of this node A have adopted the idea and 1 minus P friends of this node belong to the cluster that did not adopt the new idea. So this is the ratio. So if the node A were to adopt the new idea, then P must be greater than equal to Q. If it refuses, the node A refuses the new idea if P is less than Q. So from this P is less than Q, we get 1 minus P should be greater than 1 minus Q. And 1 minus P is basically the ratio of friends which are within the cluster to the total number of friends of A. So it's basically fraction of friends in the cluster should be greater than 1 minus Q, which by definition is the density of cluster, which means the density of cluster should be greater than 1 minus Q. So the right answer is D, greater than 1 minus Q. Okay. So this is question 9. Okay. So if you have any other questions, I can repeat. Uh, Are there any more questions? All right, then, so we can, if is there someone is okay, someone is asking to give an short explanation of the question. So the recording is available, the video will be available on the course webpage. You can take a look at that and you can skip whichever part you don't want. So explaining all the questions would be not easy over here. So if you have any specific question, you can tell, I can repeat. Short explanation, like, okay, let me try. So first question is asking about which factors influence diffusion. So which you have three options: payoff, people, key people, and cluster formation. So you'll have to decide. So basically all three of them affect diffusion. Second is when it's easy to convince a community to adopt new ideas. So this so you have two options: when the density is low or the density is high. So if density is high, then an idea, it's difficult to propagate an idea through the community because most of your friends will be inside the community and you will be rather influenced by them than by an outsider. So coming to question three, so if in a social network an idea starts from one person and reaches the other parts of the network, this phenomenon is by definition known as diffusion. Coming to question four, so what is cluster density is basically the number of friends within the cluster to the ratio of number of friends within cluster by total number of friends, and you take the minimum of all that for the all the nodes present considered within the cluster. So so density D refers to that each node in that cluster has at least D fraction of friends within the cluster. They can be more than D as well. So if the payoff of watching documentary and listening to song, you have certain payoffs and certain number of friends uh, for doing both of the activities. And by the diffusion model, so you calculate the net payoff or the total payoff, and it turns out that net payoff for watching listening to songs is higher than watching a documentary, and hence you will go with listening to songs. In question six, it's asking us how, when, and how protest is going to happen given the threshold value of each node, and you have given three networks, and so it happens in case one and case three, and it is unlikely to happen in case two. In question seven, so what is the technique to identify key people in a network, which using which idea gets very spreads very fast, very rapidly? So this is known as viral marketing. So key people are basically high connections like celebrities. So they spread an idea to a large number of people. In question 8 is again similar. So you have two activities, movie and study, and you have given payoffs. You have total number of friends on the for one such activity and another set of friends for another activity. So you can compute the net payoff and you weigh them, and that's how you decide which one to do, to study or watch movie. In question 9, so when a cascade cannot be complete in a network? So cascade not being complete is basically the idea does not spread across the entire network. So that is meant by cascade cannot be complete. So for that, we find that the cluster density should be greater than 1 minus q. And coming to question 10, so which factors causes problem in adoption of new idea. So you have again four options, and high threshold value and cluster density greater than 1 minus threshold value will create problem in adoption of a new idea, whereas high payoff and low cluster density will make an idea easy to be adopted. So that was in brief I discussed. So if you have any further questions, you can ask. All right. All right, then if you do not have any question, you can start leaving the meeting and we'll meet again next week. Thank you everyone for joining in. All the best for your course.